What's up? Today we're going to be covering chapter 2, carbon compounds. So it's a pretty complicated chapter in Form 5, and if anything it will build on like your basic understanding for the next 3 chapters. Is it 3? No, next chapter 4 and 5. Okay, so let's go through the basic understanding first. Carbon is an element in group 14, which means it has like 4 valence electrons. So let's just, now for what we know, the electron arrangement for carbon is 2, 4, which means that it has it has exactly 4 valence electrons on the outermost shell. Okay, this basically means that the maximum bonds a carbon can have is 4, as you can see here. That means if there was a double bond, so let's say a double bond here, this is 5 bonds. Carbon can't have 5 bonds, so you have to erase like one of these. See, this makes sense because it has 4 bonds. Okay, I bet you understand that, so I'm gonna go straight into carbon compounds. So what are carbon compounds? Basically, oh shit, wait. Carbon compounds are compounds that contain carbon as their constituent element. This could be classified as organic or inorganic. Doesn't really matter, because you'll find out soon enough what all that means. So basically, whether it's organic or not doesn't fucking matter. What you have to know is what a hydrocarbon is and what a non-hydrocarbon is. So basically, a hydrocarbon is just a compound or a molecule. Let's see the book definition. It's organic compounds can be classified into both of these. Okay, hydrocarbons are compounds that can be, hydrocarbons are compounds that consist of only carbon and hydrogen. So it can only have these. Okay? Non-hydrocarbon is basically any compound that does not consist of hydrogen and carbon only. Okay, let me give you a few examples. Now, hydrocarbon, let's say C2H4. Can you see that? C2H4, or you can name it as ethene. This has only carbon and hydrogen. What does that tell you? Only carbon and hydrogen. So that means it should be a hydrocarbon. Now let's say glucose. Not many people know this formula. I just know it because I see it a lot. So C6H12O6. Now glucose has carbon, glucose has hydrogen, but glucose also has oxygen. Does that make it a hydrocarbon? No, it does not. Glucose belongs here in the non-hydrocarbon category because of the oxygen that it has. So what I'm trying to say is that a non-hydrocarbon are compounds that can have carbon and hydrogen, but they must have something else in the mix. You know, this is hydrogen and carbon only. This is hydrogen, carbon, maybe some other jazz in it. Okay, I bet you can understand that. So the definitions, I'll let you read it yourself. I'm just here to explain what is what and what is not. I'll only cover the parts that I see as important. So, like other things that, I mean, there will be other things coming out for the exam, but I'll only give you the must-know parts. You can ask me about the additional details things. It's whatever, but I'm not going to cover it because it's kind of hard to explain, plus it's info that isn't really needed. So one of the infos that are needed is that hydrocarbons can be classified into two. Again, we classified carbon compounds into two, hydrocarbons and non-hydrocarbons. And then hydrocarbons itself, one of the classifications of carbon compounds can be classified into two again, which are saturated and non-saturated. So, you know what saturated means, right? Basically means like heavily concentrated. There's a bit too much of, basically. Saturated, which the saturated is in terms of how much hydrogen and carbon we can fit inside. You know, I'll explain it. So basically, you see this over here? This is called propane. Now, I'll give you the hint later, but this is just to make you understand. See, look at these. It's a hydrocarbon, consists of only carbon and hydrogen. Now, what I'm here to tell you is that hydrogen only has one valence electron. Therefore, it can only have one bond. Each hydrogen can only be connected one time to something, to carbon. So see, look at all these hydrogen atoms. They all have one line that connects to the carbon and nothing else, because hydrogen can only bond once. While carbon can bond to four different elements or atoms, whatever, atoms. Carbon can only react and bond to four. So see how each carbon atom is connected to like four different things. This carbon atom is connected to this carbon atom, connected to this hydrogen, and this hydrogen. So basically, like 4 is the max. By the way, 4 is the max. So see how everything has reached the max here? There's no double bond or anything. That means this thing is saturated. If you want to add like hydrogen gas, you can't, because there's no place to fit it, basically. So here's the tip. See how this is called propane? If it ends with "ane", guaranteed saturated, okay? Guaranteed. Because it's always almost built like this, okay? Now on to unsaturated. Alright, this here is called ethene. I showed you this just now. So ethene, you can see a difference here. While the hydrogen atoms are kind of the same as they were before, the carbon atoms have these two lines in between them. This is called a double bond. So what these double bond mean are like, since there's nothing else for carbon to react with, like, because carbon needs to bond with four things, these carbons basically reach out their hands towards each other and say, you know what, since we don't have two other things to bond with, let's just bond with each other. So boom. You can still fit more shit into this since it's unsaturated. So like, let's say that you want to add hydrogen gas. Add hydrogen gas into this. Basically, this is what happens. when you add hydrogen gas, see how it's H2? Boom. One hydrogen attaches itself to this carbon, and the other hydrogen attaches itself to this carbon. So the double bond turns into a single one, while the other bond in the double bond makes this happen, you know? So the double bond disappears to make this, and this turns an unsaturated, when you add hydrogen into ethene, it turns it into ethane. So the unsaturated hydrocarbon turns saturated. That's basically the explanation I wanted to give you. That does not make this like this before I erase the hydrogen atoms. Does not make that a unsaturated hydrocarbon. This is still the unsaturated hydrocarbon. I'm just saying that since you can still fit more shit into this, it's considered unsaturated. Got that? Get it? Okay. Let's continue. I've still got time. Okay. So what I want to cover now is I'm sure you've heard this a lot. Homologous series. So basically, let me read this directly from the book. Organic compounds can be classified by grouping compounds that have certain characteristics into one family or a series. So let's say I'm not going to draw hydrogen carbons, so hydrogen atoms, just because it's a waste of time. So just imagine them for me. What do these two have in common? There's no double bond in between them. There is no double bond, so they can be classified into one family. While this has a double bond, and this has a double bond, and this has a double bond too. So this is not similar to this, because this has no double bond. This has a double bond. So this is classified into one family. All right, let me erase this. All right. So basically what I told you just now is that carbon compounds with similar characteristics are classified into one family. These families are basically called homologous series. So each carbon compound has their own homologous series. There's a couple of them that I'll go through with you. Okay, so you can, like I said before, you can read the definitions yourself. I'm just here to explain it in a way that makes it easy for you, okay? So there are 6 homologous groups that we will cover. One is not as important as the others, but just bear with it. First homologous series we'll cover alkane. Now alkanes have a general formula of CnH2n plus 2. Now if you're fucking confused on what this means, let's say I'm asking you to form a carbon compound with 3 carbon atoms. Okay, let's sub it in now. C3, okay? H, 2 times N, 2 times 3 is 6. 6 plus 2 is 8. C3 H8. This is an alkane. This is classified under alkane. Yeah. So this has a name, but I'll tell you how to name it later. I'm just telling you that this is the general formula for it. And N can be any freaking number. It won't be that big of a number. Okay, this is just the general formula. So here's alkane. The next one, alkene. Okay, before I go on to alkene, I'll just explain what alkane is. Alkane, single bonds. All carbon bonds have single bonds, like saturated hydrocarbon. That's alkane. That's alkane. Okay. Just ask me if you don't get it. Now, alkene has a general formula of CnH2n. CnH2n. Let's say I want a carbon compound that's an alkene, and I want 4 carbon atoms inside the compound. Okay, sure. N equals 4. Sub it in. C4H. 2 times 4, 8. See how these two have 8 carbon atoms? But different. Wait, no. See how these two have the same number of hydrogen atoms? But different number of carbon atoms. That's the key difference behind it. Well, not the key difference, but one of the big differences. Okay. Now, let me draw the structural formula for this. This is not the same thing as this, okay? Let me draw the structural formula for this to make it easy for you. Now imagine each line over here, except the ones between carbon atoms, to be connected to hydrogen atoms. I'll just draw it for you, make it easier. See? Let's count. 1, 2, 3, 4 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. So you can tell by the general formula that this is an alkene. See how there's a double bond here? If there were no double bond here, it would be like this. There'd be 2 more. There'd be 2 more hydrogen atoms, which is why there's a +2 here. It'd be an alkane. But since there's a double bond here, it's not an alkane. It's an alkene, which also means that alkenes are unsaturated hydrocarbons. Unsaturated. That's the big difference between these two, okay? Big fucking difference. I forgot to mention that homologous series, alkane is basically the family name for all hydrocarbons that are saturated. And alkene is the family name for all hydrocarbons. Not all hydrocarbons that are unsaturated, but all hydrocarbons that have a double bond inside them. There's other unsaturated hydrocarbons, which is what I'm going to tell you right now. Alkyne. Alkyne is also an unsaturated hydrocarbon, but what makes them different is what I'm going to tell you. Soon. This is the general formula. CnH2n minus 2. Let's say I want 2 carbon atoms. Okay. C2H, 2 times 2, 4, minus 2, 2. That's a bit weird, but okay. Now, it's supposed to look like this. This is what we call a triple bond. See, since you can absolutely fit more hydrogen atoms inside, it's also considered an unsaturated hydrocarbon. Alkynes are not really important in this chapter, so You don't have to remember this. Now alcohol. Alcohol is a special case. See, instead of being, after alkane, alkene, alkyne, we move on to non-hydrocarbon territory. So alcohol has oxygen in it. I'm going to tell you how. Basically, the general formula is like this. 2N, but instead of plus minus 2, it's plus 1, and then there's an OH at the back. This is the OH. OH, or also known as hydroxyl. Hydroxyl is the name of this, okay? That hydroxyl is the functional group of alcohol. Functional group is basically the defining characteristic, the defining character trait that makes them different to others. The characteristic that defines the whole family, defines the whole homologous series. So I'll verify that soon. I'll give you more info on that. I'm kind of running out of time. So alcohol, hydroxyl. I'm sure you know how to do the formula shit right now. So basically, I'll give you an example. Ethanol, a popular alcohol that can be used, that is also, that motherfuckers drink, okay? Yeah, that's an example. And then, oh yeah, I didn't draw the structural formula for you. Okay, let's make it, I'll just draw it for you. Alcohol. Ethanol, to be precise. Look at that. Now see how it looks a bit different because of this OH up here. This is just the simplified version, but OH is supposed to look like this. It's because oxygen has 2 valence electrons. That means you can bond it to 2, connect it to. So yeah, it looks like this. That's ethanol for you. I'll explain more when we go over chemical properties, but this is how it looks. It's what happens when you add water to ethene. Now this is pretty long, but once you get it, you get it, okay? General formula. See, the starting is the same as alcohol. 2N plus 1 COOH. All right, let's say I want one, okay, let's say I want 1 carbon atom. 1 carbon atom? What? Okay, so like basically CH 3COOH. There's 2 carbons here, so technically there's not 1 carbon atom, but since n equals 1, we just sub in 1. You'll get it later. This is called ethanoic acid. Now once you know about the names, you can ask me again, okay? Ethanoic acid. It's an acid, so that's what makes it special, because this is the only one amongst all homologous series that has hydrogen ions and has acidic properties. So like, go back to acids, bases, and salts. You'll know what that means and what ethanoic acid is capable of. It's a weak acid. Lastly, ester. Ester has a long general formula. See? They won't ask you to sub in And like I just told you to, this is generally how esters look like. Esters are basically formed when you get an alcohol, carboxylic acid, mush them together. So basically, let's say I used ethanoic acid and ethanol, like the two examples I gave just before this. Ethanoic acid comes first. Oops. This ethanoic acid, where did the sole hydrogen ion go? It's gone now. Because it let go of the hydrogen ion to bond with alcohol. This alcohol. In this case, is ethanol. Boom, ester. We call this ethyl ethanoate. Again, I'll cover this later. This basically just tells you all the homologous series. Okay. Know that everything in carbon compounds is basically covalent, but the only exception being carboxylic acid. But that still doesn't mean anything. Basically, that means the more carbon atoms there are inside, so let's say C2H4 compared to C5H10. Obviously, this is going to be denser than this, but because of covalent bonds, van der Waals forces of attractions, intermolecular forces of attractions, the melting point of this is lower than the melting point of this. So like this needs less heat to boil it, to melt it. This needs more heat to melt it or to boil it. Okay. The last part I'll cover is how to fucking name the compound. This is the important informations, basically. The number is only in terms of carbon atoms. So if the homologous series has one carbon atom, for example, methane, 2 times 1 plus 2. Methane. See how this has one carbon atom? 4 hydrogen atoms. So from the general formula, we can assume that that n equals 1, because 1n, 2n, 2 times 1 plus 2 equals 4. So basically, the number of carbon atoms is 1. Meth. And since you judged that from this thing is an alkane, so the name is meth plus the 3 letters here, ane. This is methane. Methane. Now I'll let you. I'm testing. I've shown this compound a lot recently, so I want you to name it. What homologous series is it? Basically, what family is this? And what the name is. This is called the prefix. What is the prefix? What is the homologous series? If you said that this is an alkene, you'd be right. And if you guessed that the prefix for this would be F, you'd also be right. Now tell me what the name is. I hope you got it right. ethene. Congrats, if you got it right. Now, it's kind of the same for alkanes, alkenes, and alkynes. For alcohols, alcohols, both carboxylic acids and esters, it's a bit different. I'll only cover alcohol and carboxylic acid. Esters a whole different case. So let's say, oh yeah, I'm only giving you 1 to 4 because these are the only important prefixes. Like everything else, if you know geometry, you should be able to know it. Like 5 carbon atoms would be pent, like pentagon, which has 5 sides. 6 carbon atoms would be hex, like hexagon, which has 6 sides. So it goes up to 10, like starting from 5, pent, hex, hept, okay. Pent, hex, hept, oct, non, dec. Okay, if you know geometry, you should get it. These are the only 4 that are not correlated with geometry. Okay. All right. Alcohol. Let's say the alcohol has 3 carbon atoms. So from the formula up here, sub in how many carbon atoms there are, would be so you've got prop, and this is also called alcohol. Basically, you want to get the end of the word here, but add an an, so it's going to be anol, prop anol. So this is propanol. Same with ethanol, same with methanol and butanol. So yeah, there's always an anol at the end for alcohols. Next, carboxylic acids. This one's pretty easy. Now let's say 4 carbon atoms. From the general formula, we can already guess what the chemical formula is supposed to look like. 2 plus 1, 2 times 4 plus 9. 2 plus. Thank you. COOH. 4 carbon atoms. So obviously you think, oh, it's boot. It should start with boot, right? Wrong. No. Even though there's 4 here, there's another one here. See? So this is 5 carbon atoms. So it would be pent. Pent. And since this is a carboxylic acid, you're supposed to attach it to anoic acid. Okay? Pentanoic acid. Ben. So you might be confused about these carbon atoms. So I'll give you another example then. How many carbon atoms are here? It's 2. 2. Even though this is 1, even though the N here is 1, there's also a carbon atom here. You have to consider this, okay? So this would be named ethanoic acid. Because there's 2 carbon atoms here. Now, you might be thinking, what about methanoic acid then? Simple. This is methanoic acid. Now, when you try to apply the general formula here, it doesn't really work. So this one you kind of have to memorize. Like, yeah, The general formula only starts working whatever. I mean, when it comes to carboxylic acid, it's kind of complicated, but I'm sure you got it, right? I'm sure you got it. So yeah, that's basically how you name it. So yeah, I'm kind of running out of time. Shit, that's a lot of time. Peace.